Chris Fantine, Chief Technologist for the Western region in North America at Red Hat. I've been with Red Hat for about 13 years. I work with strategic partners and customers who are adopting Red Hat's emerging technologies centered around DevOps and containers most recently. And so today we're going to talk about how Kubernetes can enable DevOps as well as integrating security into that as well. First off, though, let's talk about some of the industry drivers. You know, Andy Grove back in the 90s talked about how only the paranoid survive, and it wasn't about security, but it was about when there's massive amounts of change in the industry and a company has to make a decision, you know, do they pivot, change course in order to potentially thrive, or if they stay as is, they potentially can fall by the wayside and become irrelevant. And we're certainly seeing that across many different industries, retail, finance, media, etc. The incumbents are being disrupted by the disruptors. And software is a key part of this disruption, whether it's Amazon, Apple, Netflix, etc. And as I talk with folks in the Silicon Valley, many of the companies, you know, the root cause of this inability for them to kind of deliver innovation quickly and keep up with the disruptors is the organizations have evolved into silos, right? Developers, QA, operations have all kind of evolved, kind of like an island, and as a result, they've evolved with their own processes, their own tools, then their own language, and it becomes very difficult to move software from dev test into production quickly. And so there's a lot of pressure in IT to not become the bottleneck and to keep up, and so they must evolve, right? They must evolve how they develop software, how it's architected, how it's deployed, and where it's deployed on the underlying infrastructure. And that's why you're seeing a lot of pressure on IT to keep up with the business, to enable innovation, and rapidly be able to release software into production. And so there's a movement towards DevOps, breaking down those walls, bringing together developers, operations, security, the line of business as well, into a virtual team that's gold similar, and they can rapidly move software into production around tooling and processes and continuous feedback as well. In terms of microservices, you know, decoupling that monolithic application so that you don't have to bet the entire business every time you do a software update. Right? How do you reduce risk? How do you enable the business to rapidly innovate and move new capabilities into production quickly? Well, decoupling that application and making it smaller parts so that you aren't betting the business every time you do a deployment. And it doesn't make a lot of sense to have that smaller component packaged in a large-scale virtual machine. You know, something that's smaller, lightweight, such as a container, will enable you to have that iPhone-like experience in the enterprise, right? Why is it so difficult to deploy software in the enterprise, yet so easy on your mobile phone? And that's what containers are all about, is being able to build that application once and deploy as is across dev, test, into production, and simplifying and making it a lot more efficient across public, private, virtual, or physical machines. And, you know, around DevOps, one of the key enablers is certainly continuous integration. I show this. Does anybody recognize what this is a photo of? Right, this is the Intel fab that they're building out in Arizona right now. And I show this because back in the 90s, you know, Intel has always been known for their fabs. It's been a strategic differentiator that's kept them ahead of the competition. They've been able to shrink their die size, increase yields, lower the power, improve power just through manufacturing. Right? It isn't the architecture, it wasn't the design. But back in the 90s, they had the Pentium bug. Does anybody recall the Pentium bug? Right? Caused a $500 million write-off for the company, negative PR. And Andy realized they weren't responding quickly enough to customer feedback. And he realized they can't just rely on this physical factory. They need a software factory behind this. And so they invested millions of dollars in building out a Linux-based cluster, which allowed them to continuously integrate their chip designs and get them validated across the entire chip, and they were able to get instant feedback, and they were able to respond a lot quicker to customer issues. And so it was a cultural shakeup and a process change as well for them. So continuous integration. Another factory. Does anybody recognize this one? Yes, this is the Tesla automobile factory. And I show this because the other key part of DevOps is continuous delivery, continuous deployment. And certainly software is a key part of this factory, the robotics and the automation, increasing the rapid production of these vehicles. But also, it has totally transformed how these vehicles are updated on an ongoing basis, as well as the business model. So now with these vehicles, for the first time, when I leave that dealer lot, I know that that car is going to get better 6, 12, 18 months down the road because they have software updates over the wire, right? So for the first time, I can get better battery efficiency, maybe better 0 to 60 time, or newer applications with additional functionality just because of a software update. And if there's a security issue, well, I don't necessarily have to do a physical recall, saving them tens of millions of dollars from having to bring these cars in. And so that's going to be very important, especially with autonomous driving. Not only that, but they've presented a whole new business model. I can charge a subscription now for this software update service as well. So very important for the business, this change. Also, in terms of DevOps, it's not just about the technology. Certainly culture and process are key contributors to this transformation. From a cultural perspective, transparency, inclusion, representing a lot of the characteristics of the open source communities, borrowed from that. And then from a process perspective, having continuous integration, continuous delivery, as we just discussed, but also having that continuous feedback loop so that you have your eyes on what's coming on in the production environment or with your customers and can quickly change course and pivot and roll out that new capability. And that enables the process around the technology, which builds out what I call your software factory. Right? This is the factory that Intel had behind their chip fab. This is typically built on open source these days with Linux, containers, or even at the IIS layer, as well as the developer tools as well. But what about security? When I joined Red Hat, talked with a lot of customers about whether security processes, etc. They would typically say, well, those servers are not in the DMZ, so we don't patch them. Right? And that was certainly, a short-lived process. Certainly, these customers know firsthand, and many, many more do since, because they represent these logos over 1 billion data records that have been breached in 2014. This data is from. Most recently, certainly you've seen the headlines, maybe in the U.S. With Equifax being breached, over half of the records being compromised. Several of the executives, including the CEO, have immediately retired as well. And so having a significant impact, security issues in the enterprise. And so there's an important need to actually include security as a part of this DevOps transformation. And so security is not just tooling, but it's in the culture too. Having a security is important, security first mentality, and embracing that across the organization. Developers, tests, operations, the business unit, as well as the security team, as well as incorporating it into the process, and we'll talk about how, and some of the tooling that can help you with that, in particular around containers. And containers are a big part of the security story because they allow the developer to kind of free up and move quickly and keep up with the DevOps movement and drive the requirements of the business, yet still adhere to the security standards of the operations and security teams. Right? And they do that because they can actually abstract their application from the host operating system and can incorporate the libraries that they need for their application as well as the operating system within their application. And we'll talk about the details around that. From a generic perspective around containers, what is the basic flow? First off, the developer creates a build file, and this build file is really your blueprint for how to build the container image. And from a security perspective, it's important to have this recipe so that you can go back and always recreate your images back in time. You also, as a best practice, want to version control that as well. Secondly, once you build that container, and you build it once, you're not building it again in test and production, you can store that in a private or public registry. Right? So it's a best practice in the enterprise, certainly, to bring that into a private registry, and then also to be able to run that on a secure host. And we'll talk about some of the best practices around that. And so the key things around containers are it has a standard image format and a standard runtime. Similar to the Java world, you have a standard JVM and the standard jar file, except it's for any language. Right? But when it comes to containers, that's great on your desktop or your laptop. But when it comes to the enterprise, there are a lot of considerations you need to think about in terms of your capabilities. First off is scheduling. How do you schedule containers across a data center or multiple data centers or availability zones, and efficiently use the resources and make sure that the requirements of the application are fulfilled. Also, how do you manage the life cycle and the health of your containers? Right? How do you move that container from dev test into production, and how do you monitor and make sure that that container is up and running and you don't have to get a pager call at 2 p.m. Also, as you deploy a microservice, you need to be able to discover other services that are available for your application out on the cluster. Monitoring, you want that continuous feedback loop, and the ability to scale, right? The days of submitting a network engineering ticket to update the load balancer, to add capacity are gone. How do you have that in real time, intelligently scaling up and scaling down based on load? And how about persistence, right? These applications, maybe some of your legacy applications have some monolithic databases. You want to be able to bring those over into a containerized environment. And you want to be able to logically manage and orchestrate your applications that consist of multiple microservices, as well as talk about the security capabilities within your environment. And so that brings us to Kubernetes. A lot of shops started out around containers, doing things manually, maybe writing scripts around DevOps as well. How do you commoditize that, and how do you automate that and bring a solution that's out of the box, secure, as well as being able to manage containers at scale and orchestrate that application from dev, test, into production without taking your developers and actually having to write that management code yourself. And that's what Kubernetes is focused on, is bringing efficiency to managing your container application environment out of the box with security in mind. And so as we deploy containers, there are many questions around security that customers have. Are there any known vulnerabilities in the application layer of your container? And we'll talk about that. Are the runtime and OS layers up to date within the container? How frequently will the container be updated, and how will I know when it's updated? Is the image from a trusted source? And can you quickly deploy a security update at scale? Right? How do you get it out scale in an automated fashion in a matter of minutes or hours? Right? And then, is my multi-tenant host secure as well? So what are some of the best practices to ensuring multi-tenancy? And so we're going to talk about how Kubernetes brings many security capabilities to the platform, from container hosts to the images, builds, registry, CI/CD process, as well as the bottom here, network isolation, storage, API monitoring, and federated clusters. So first off, let's start with container host security. First off, at the host level, it's important to know that containers are really Linux. And Linux provides a lot of security capabilities to ensure that you can have multi-tenancy on your particular host. C groups provides quality of service, right? So that's important so they don't have a noisy neighbor problem. Right? You don't want to be sharing this infrastructure and have someone overconsume memory, CPU, etc. And so C groups allows you to place limits on the individual container processes. Namespaces provide kind of a virtual system at a container level, and it provides a unique environment so that, for example, the root user ID in a container isn't the root user at the host level. And that's important in a security perspective, because if someone hacks into your container as running as root, you want that user to be root at the host, because then they're root everywhere and your containers can be compromised. So namespaces provides protection around that. And then also SE Linux. SE Linux provides mandatory access control. This means that you have to explicitly state, even on a root process, what resources it has access to. Right? So even if I'm root, I can't access every file unless it's explicitly stated that I can access that particular file. And so that provides security extra layer in a container-based environment. Very important as well. In terms of best practices on the host level, here are a few. First off is try not to run your processes as root on the host. You also want to limit SSH access as well. If you need information from your container, it's best to set up some sort of API service and remotely access that. Use namespaces for the reasons just mentioned. Also, make sure you're defining limits on the resources. Right? Set those quotas to ensure a good quality of service in a multi-tenant environment. Enable logging, so Kubernetes has a logging capability when you can aggregate those logs. Don't forget to apply security errata not just to the container, but also to the host. So there's two layers, because the container does have libraries from the OS or the application. And then Kubernetes can also apply automatically security context. You can limit basically the kernel capabilities of the process so that you can kind of filter out and kind of take a proactive approach of limiting potential vulnerability exposure at the kernel level. Next, we're going to talk about the container image security and some best practices there. So first off, it's important to understand the fundamental difference. As a developer, you may be coming from a world where you're delivering to operations or your test team a jar file, right? And then they provide the host operating system, the application platform. Well, in the container world, when you build your application, it's actually pulling in all of its immediate dependencies. That might be some of the application runtime as well as operating system components. And so that's a fundamental change here, is that those components that were typically owned by the operations team are now being owned by the development team. Right? So from a security perspective, who owns it? Who's going to check for security notifications, and who's going to update it as well? Right? Well, the nice thing is with containers that you can normalize the language that everyone is talking and building upon with the Docker file. And you can layer those components of the container. So you can continue to have the operations team own, for instance, the core build, and they can define that in the Docker file. The middleware team can depend on that, but layer on top the middleware component, maybe it's their Tomcat server. And then thirdly, the developer can layer on top their application code, all using the Docker file. So that's very different than today's world, where you have the admin using a kickstart file perhaps, and then the middleware team using a tarball, and then the development team delivering a jar file. Right? So we've normalized this. We're speaking the same language, a key principle around DevOps. And each individual team now can continue to own security notifications, security updates for those layers. Right? And it's important to know what's going on in the container and what's being pulled down. Many organizations are pulling down public images from the Docker Hub, and need to be aware that there are OS and application layer components in there, and they have potential security issues. Here you see a C, a Java, a Node.js, and a PHP application. And you see the components that application pulled in when I built the container image. Right? For instance, the Java application pulled in the JRE, and it has 66 security notifications, in this case, since RHEL 7 was released. Right? So not only is it important I know what I'm bringing in and where I'm getting it from, but also I need a process on an ongoing basis to continually check and scan to make sure. So in the organization, who has the responsibility for doing this? That's something that needs to be clearly defined. Another best practice here is to, especially if you're using new application development, is to treat them as immutable, the container. Right? This means separating the code from the config and the data. Right? And the code would go into container image in Kubernetes, and then also the configuration can be stored in some concepts called config maps or secrets. Right? Secrets are, if it needs to be encrypted, such as a password. You can store these like in environment variables, etc., and be able to keep this separate from the actual container image. This allows you to scale up and scale down quickly and be able to dynamically change the configuration without having to rebuild the container image by keeping it separate. If you need to access remote data, you can store that in a data service, traditional data service, or Kubernetes provides the ability to provision out persistent volumes and store data there across the cluster. Another best practice around images is to make sure you're signing these images. Right? So in Linux distributions, they provide the ability to sign the container image. That way you know if it's from a trusted source. So you may want to check that, and Kubernetes can check that to make sure it's been signed before it starts that container image and creates a container instance on a particular host. Next, we're going to talk about container registry security. Right? So we talked about a little bit of the container image security. We ran a scan on the public registry Docker Hub at one point, and 64% of them had a security issue, either high or medium. Right? So your developers are probably pulling out these images from the public registry. If you're in an enterprise, you need to address that. You can continue doing that in a development environment, but when it comes to production, you probably want a private registry in your enterprise. And I'd say this is the first thing most enterprises do, is they set up a private registry within their firewall so that they can get a handle around what images are being used within the organization, who's using them, who's building them, who's creating them and storing them as well. And another best practice, developers are pulling in their Docker file, they're probably specifying third-party components in remote public registries potentially. Well, what if that public registry goes away in 6 months? How are you going to rebuild that image down the road when a bank has a security issue and you got to go back and recreate an environment that's on a version that's 3 years old? Right? And so by storing it in a private registry, you own the backups, et cetera, and the retention of those components. So it's important to have all your components in a private registry. For experimentation and innovation, certainly leverage what's out in the community. Next, we're going to talk about continuous integration with containers. So this is a typical CI/CD flow with security in a container environment. So first off, you have your operations and your developers. They're probably checking in your Docker files or source code, version controlling them. Right? Everything needs to be version control. And then you have a build environment. So with a container image, you want to make sure that you can reproduce that container image in the exact same way. Right? So that means you don't build your image in the same container that's deployed into production. Right? There's a concept of using a build image. The build image is used to create the container that's apart from the build image. Right? So that artifact is separate, and it will just contain the application runtime dependencies, as well as the OS dependencies. So another advantage is having that to be a lightweight footprint. It's reproducible, and you've reduced the security attack footprint. And then I would store that once in my image registry, and then I would take that image and push it into my testing environment and push it out into my production environment. So build once and deploy everywhere. In terms of best practices on the builds, treat it as the blueprint, the Docker file. That way it's reproducible. I know the recipe. Don't SSH into a container, make changes, save it, and deploy it, because when that engineer goes away, who knows what was changed in that image. Same principle as in a physical or virtual machine. Also, version control, save those build files in the source code repository, Git, etc. Make sure you're explicitly stating what version, so that when you go back 3 years down the road, it gets reproduced with the same versions. And then be mindful that every time you put a different line run command in the Docker file, it's creating another layer. So you want to minimize that as well to be efficient. And then also, how do you incorporate security in your continuous integration process in an automated way? Right? This is a Jenkins build. See the pipeline, different phases. Well, what we've done here is actually added a phase to do a security scan. So every time you build an image, run it through an automated security scan. A scan for security policy, a scan for security vulnerabilities. You could also automate this with your private registry. Every time you push to it, trigger a scan as well. Right. And so this shows you how to do an automated rebuild. And so we talked about the separations of responsibility. And so the operations, the app team, and the developer here, if the operations team updates the base image for the container, you can automate an automated rebuild of anybody that depends on that upstream, or downstream, sorry. And then also, so middleware depends on the core build, application depends on both. So if one of these images gets updated in the registry, you could trigger an automated rebuild in development and then push that to test and then push that to production. Now, how automated you do that process is really up to your organization, but it could be fully automated. And so how would you scan automatically your images? Well, there's several different tools. Third parties like Black Duck or Anchor have deep inspection tools around containers. OpenSCAP is an upstream open source solution which allows you to do compliance security checks as well as vulnerability audits. And so OpenSCAP really does three things around content, scanning, and reports. From a content perspective, we provide for the different distributions, the OpenSCAP provides a security policy. Right? And there's many different policies which we'll talk about, but basically this is a checklist. Is the image configured to comply with my policy around daemons that are enabled or disabled, or password security minimum length, etc. And then also we provide a known vulnerability list as well. And so you can scan that to see on an RPM basis, are any RPMs with a known vulnerability installed? And there's a variety of scanning tools to help you out. There's a daemon, there's a CLI tool, there's a policy editor, and there's also integration. For example, if you want to manage at scale with Foreman or manage IQ communities as well. And once you run these scans, it generates reports, and we'll talk a little bit about the reporting that you get. But first, in terms of security policies, there's a lot of out-of-the-box policies that are provided that the tool can use, whether it's around a Docker host or a virtualization host, different government standards or PCI compliance. You can leverage these out-of-the-box policies and customize them to meet your needs, and then run the scanner against a physical, virtual, or a container at rest or running. And so the report that it generates, here's an example for the security policy. And so this used one of those standard policies, and then it ran it against the container image. It could be on an NFS share, or it could be something live and running. And it'll show you if it passed or failed the individual checks. And then I can actually drill down into one that failed for the minimum password length, and it'll actually generate a remediation script for you that you can run on that image to rectify that issue. Right? And the newer version, it actually provides an Ansible script as well. And so you can automate the remediation of that. Here shows you an example of the report for security vulnerabilities. So this is when it does a pass on the image to see what RPMs have known vulnerabilities, and then it provides remediation by recommending to update that particular RPM to a newer version that addresses that issue. All right, so we talked about continuous integration. How about continuous delivery? All right, so this is really, how do you roll out into production your updates? And let's go back to the first slide. Key difference here is that we're moving from a world where the developer is delivering a jar file. In that world, typically operations own everything outside that, and then they would, if there was a security vulnerability, they would just go and patch their production servers with a particular update. But now we're moving to a world where you have the application with the runtime and the OS within that container image. Right, that process doesn't work anymore. Right, I have tens of thousands maybe of containers out there. I'm not going to go and patch or modify these containers. I need to go back to step one in my software factory. I need to go back to development, right? And some of the reason why operations would go out and patch these hosts is how long did it take in the old days to move something from dev into production? Some organizations say 6 weeks, 6 months. Right? With a software factory that's automated now, you're going to be able to go from dev into production in a matter of minutes. This allows you to go back to step one. And the advantage and the value that you gain is that now everything that goes into production, first of all, in Kubernetes, it allows you to provision a development environment, a QA, a staging, a production, a virtual environment that's a mirror of each other. So now I have access on my laptop, in my server farm, to production. So issues aren't going to be discovered for the first time in production. I'm actually testing on a production environment. And I can now build it once and then push it into QA, do the testing with that security update, move it into staging, move it into production. Every time you go back to square one. That eliminates manual configuration, etc. Well, in order to do this quickly, I need some deployment strategies that allow me to quickly roll out and allow me to do this at a low risk. Right? I want to be able to test it out, see what the impact is, and then be able to roll back gradually as well to an old version if there is an issue. And I want to try to do this with zero downtime if I may need if that's a requirement in my environment. And so Kubernetes out of the box provides some deployment strategies. You can do blue-green deployments, rolling updates, canary deployments, A/B testing. And this may not be new to developers, but what's new is that I don't have to manually script all this. Right? Out of the box, it provides automation around these deployment strategies. And so as a developer, I can focus on coding rather than creating this infrastructure or code pipeline. So blue-green deployment, what it can do is, there's a software load balancer in the Kubernetes that can back into your and control maybe an F5 hardware load balancer as well. So if I have version 1 routing all my traffic, I can create a separate environment running version 1.2. That is a virtual environment running on the same physical infrastructure. I'm going to put that through CI testing. So maybe there was a security issue. I want to quickly address it. And then I can update my load balancer automatically to route all the traffic over to 1.2. Now, if there's an issue, I can easily flip it back because the blue and the green environment coexist. They're logically two different environments. Right? So I haven't replaced version 1 with version 1.2 environment. Secondly, maybe I want zero downtime. And so here I could do a rolling update. Version 1 is out in production. I have version 1.2 being developed. It's going through CI testing. And then it's deployed. Kubernetes, if for more complicated applications, maybe you want to make sure that that application has access to the database and it's responding before you update the load balancer. And so you can take advantage of the health checks, readiness probes. You can do TCP, HTTP, or write a script to do a check. And once that check completes successfully, then it will add it into rotation. And you can gradually update the nodes one by one or have an automated gradual rollout. So as you gain confidence with the update, you deploy it to more capacity until it's 100 as well. And so we talked about container hosts through CI/CD. Kubernetes also provides security capabilities for network isolation. Right? So you may have multiple applications across your infrastructure. You want to have restrictions about what's going in and out from a pod or a service. And so we have network policy to define communication restrictions between applications or services as well as entirely different logical networks. Right? And that's how you get these virtual environments, dev, test, production, etc., on the same infrastructure and have that isolated. Also, storage. You can apply that policy to restrict what goes in and out of your persistent volumes. Also restrict who has access to the APIs to provision storage. There's also the ability to limit storage quotas and define that. Overall, API and platform access, there's restrictions there that you can set up in policies. Monitoring and logging has built-in logging, so it does aggregation, typical like elk stack. And then also federated clusters. So this is where a lot of development is going on now, is to be able to have a single view across multiple clusters. Maybe it's a private public cloud, or maybe it's multiple public clouds. So the ability to have multiple individual clusters and then have a centralized API or aggregation across the CLI and the GUI. And this allows you, from a security perspective, maybe you have different environments that require different security standards. And so you could actually deploy the application to the appropriate environment based on the security requirements and checking what the security configuration is for that cluster before it gets deployed. As you make this transition, some good things to take a look at from a metrics perspective is one is you want to keep track of the compliance score of your images, make sure that they're meeting whatever threshold you set in place. Also, the deployment frequency. Is this software factory enabling you to deploy more frequently? Also, the lead time. How long does it take to get from dev into production? Track that. What is the deployment failure rate? How long does it take to recover when there is an issue? You want to be able to measure that. And then also, of course, the service availability. Make sure that this transformation hasn't negatively impacted what's critical to the business as well in terms of uptime. All right, I want to thank you for attending. I'm on LinkedIn. I also have, you can reach out on email and Twitter as well. If you have any questions, feel free to ask them.
Thanks a lot, Chris. Time for one quick question. Anyone have? Raise your hand. Anyone? Yeah.
Relatively non-existent experience of OpenShift. There was an OpenShift badge on top of Kubernetes. How does, in a couple of words, how does that fit on top?
Oh, sure. So OpenShift is our Red Hat's distribution of Kubernetes for the enterprise. We also have it available online as well as installable in a private data center. Cool. And one of the advantages of OpenShift is that it really adds a lot around the developer experience as well as the automated build aspect.
Okay.
Whereas Kubernetes today is focusing more on the automated deployment, the CD part of it.
Cool. Sweet. People have a question afterwards. You're around? Or?
Yeah.
All right. Thank you so much,
All right.
Chris.
Thank you.